Hi sir, I am Tan Chongyi from Group 1. The sensor that we use in our project is this MEMS capacitive vacuum sensor. The operating principle of the design is based on the deflection mechanism of the diaphragm by applying pressure on it. The relationship between the deflection and pressure is very important in this MEMS capacitive vacuum sensor. This is the cross section of the sensor, and this red color circle is the part that the pressure is applied on it. Apart from that, capacitance equation and sensitivity equation is also included to calculate the total capacitance and then calculate the sensitivity of the sensor. This is the simulation result from our ANSYS simulations. This is the MEMS fabrication simulations. In our layout is begin by a substrate. After that, dope it with silicon dioxide on the bottom and etch a circular shape on the top of the silicon substrate and drop a layer of silicon dioxide on top of it. After that, bond SOI, which is silicon on insulator on the top of the substrate. After a few steps of etching process, it will left with boron on the top. Etch a circular shape on the boron and implant electrode to the sensor. This table is show the step that just now I explained, and this is the material database, which is shown the material properties about silicon, silicon dioxide, chromium, boron, nitrate, and carbonate. And this is the layer layout with various type of shape is shown in this table.
My name is Joe again. This is our MEMS fabrication simulation of the MEMS Pro design. The gray color indicate for silicon substrate, green for boron diffusion, yellow for electrode, red for silicon dioxide, and purple for SOI wafer. We have good substrate, hence we have a process called bonding to bond this cool of the substrate. And then, lastly, the SOI is age and the shape of the graphene is formed using the specific mass. And so this is our final 3D model of our MEMS capacitive pressure sensor. And then this is our diaphragm of our sensor. So the pressure will be exerted at here. Hence the displacement or deformation of the diaphragm will be recorded so that we can calculate the difference of the capacitance and the sensitivity of the sensor by using different kind of material of the diaphragm. Thank you.
Hi, I'm Anka Singh. I will explain the MEMS finite element analysis. It is begin from the material with property will insert to the engineering data, which include the value of Young modulus and Poisson ratio. For silicon dot with boron, silicon dot with nitride, silicon dot with carbonate, followed by construct geometry in space plane with different parameters. Circular diaphragm with 4 micrometer thickness, circular diaphragm with 2 micrometer thickness, square diaphragm with 4 micrometer thickness, and square diaphragm with 6 micrometer thickness. In model, it will undergo meshing. Lastly, the pressure and fixed support will apply on the sensor to get the total deformation.
Hello, my name is Hoyi. For me, I will proceed with the ANSYS solution and result. These are the 4-line graph that we are obtained for the overall of the total deformation versus the input pressure. Well, for the various diaphragm material, we are using is Si boron, Si nitrate, and Si carbonate. Well, for the various diaphragm thickness, for the circular, we are using is 2 micrometer, while for the square is the 6 micrometer. The various input pressure we are used to obtain the total deformation that we want. Based on the total deformation that we are obtained, the circular diaphragm with the various diaphragm material is the largest one, followed with the circular diaphragm with the various diaphragm thickness, then followed by the square diaphragm with the various diaphragm material, and the lastly is the square diaphragm with various diaphragm thickness. So that's all for my part.
MEMS capacitive vacuum sensor help for campus sustainability. As previously, timing is the factor that determines the amount of water for washing machine cleaning cycle. However, recently, due to development in add-on for sensing the pressure referred to the water level, help to get the measurement in high accuracy. The manufacturer providers such Panasonic next-gen intelligent smart sensing technology washing machine let residents reduce overall water use. It would precisely regulate the amount of water required, which help to greatly environmental saving can be made.
After finishing this project, MEMS capacitive sensor for campus sustainability, we expect we can achieve goal number 6, 7, and 11, which are green worker and sanitization, affordable and green energy, sustainable cities and communities. Worker management is a global environmental challenge as our known. So if a proper waste of a worker occur, it will create numerous environmental issues such as water pollution, health problems, and energy waste. So we need to avoid this to happen. So a smart worker management is proposed by utilizing a MEMS vacuum pressure sensor. It is because this smart washing machine will create higher efficiency in terms of resources and costs associated with keeping the worker clean and reduce the worker waste.